morning class. So today we're going to be doing a problem from lesson 2.12, which reads, Emma, who weighs 55.0 kilograms, drops from a height of 50.0 meters with a 30 meter, 150 newtons over meter cord. A asks, if the drop is 80% efficient, how close will she get to the ground? And B asks, if the drop is 100% efficient and the cord has a mass of 10.0 kilograms, how close will she get to the ground? So, starting off, we know that the energy type that is present in point 1 is GPE because they haven't dropped yet. And in point 2, we're going to set it to only EPE and set the lowest point, the height of the lowest point, to 0 so that we don't have to worry about GPE. And in doing this, we don't know what H1 is, but we know that it is equal to the length of the cord plus the stretch. So height 1 is 30 plus x. And since in part A there is an efficiency value, we can put that onto the GPE value E1 so that we can get E2. So E, and we know that E1 is GPE1 is equal to EPE2. And then knowing these are, we can just plug in the values. E is equal to 0.8, M is 55 kilograms, G is 10, and H1 is 30 plus X, which is equal to 1/2 150 times X squared. Using the stretch, we'll be able to find out what height 2 is equal to. When we do all the math out, we get 13,200 plus 440x is equal to 75x squared. And when we write this out as a quadratic formula, we get this, and then when we solve for x, we get 16.5 and negative 10.7 meters. And we're not going to be counting the negative stretch values. So knowing what x is, we can calculate for height 2 by taking the total height, which was 50 meters, minus the length of the cord, minus the length of the stretch. And from this, we will get the height 2 is equal to 3.5 meters. And now to solve for part B. In this part of the problem, efficiency is equal to 100, so we don't have to put the E value because it's 1 times E1 is just E1. And E2, except